Hello everyone, and welcome back to a new video in programming the Finite Element Method using MATLAB. And in this video, we are going to continue from where we stopped, which is basically talking about the supports. So today, we're going to program the basic support and add it to the node. Now, if you are new to this video series, please notice that this is the continuation of the Finite Element Method video series that I will be linking on the top right. And this is part of a sub-series, which is, well, programming the Finite Element Method in MATLAB. And it also has its own playlist, which I will also be linking on the top right. So if you stumbled upon this video by chance then, and you're wondering where this is in the grand scheme of things, then you can check out that linked playlist on the top right. So okay, we want to do supports, so without further ado, sit back, relax, and enjoy the show. Alright, now before I start, let me just do a quick rundown to see if everything is working so far. So far, I can create nodes, I can create lines, and I can plot a simplistic plot, which will be expanded upon, like adding, for example, the cross sections and adding a 3D model of the node and so on. But for now, this is good enough to get a quick view of what we are defining. Okay, now we want to do supports. So of course, I need to open a new file. I will close the viewer and I will close the line. I'll keep the node because I need it. The str node is needed here because supports are a property of the nodes, but I need to define them first. So I'll click on new script here. And of course, this is called the STRSupport. So I'll save that. Fantastic. Now I have my STRSupport saved. Now I need to class def it. So class definition, STRSupport, to signal to MATLAB that we are going to be using the object-oriented programming paradigm. So if I class def something, I will end the class def. And now we dive into the insides of the class def. It's going to have some properties, which are basically the things that it has. And it will have some methods, which is basically the things that it can do. Now, I don't think a support can do anything. So first of all, the methods, it should be able to create itself. So I need a constructor, meaning function and object equals STRSupport. That is the constructor. Now here, for an STRSupport, I want the constructor to have the following. I want the user to pass in an ID for the support, a unique identifier. I want also the user to pass in the stiffness of the displacement spring, the stiffness of the displacement spring in Y, the stiffness of the displacement spring in Z, and KRX, the stiffness of the displacement of the rotation spring in X, around X, the stiffness of the rotation spring around Y, and the stiffness of the rotation spring around Z. Now, you might be wondering why I'm asking for spring stiffnesses, although it's a support. You see, the way I am going to model supports is not simply the dashing things from MATLAB. It's not going to be simply the static condensation where we remove rows and columns. No, I'm going to allow the user to provide an elastic support if he wants. An elastic support can be used to mimic, for example, raft foundations or beams on elastic soil. Now, what about a normal pin or normal fixed support? If you want to define a normal pin support, then this would cause the stiffnesses to go to almost infinity. And if you want to define a pin support, then the stiffnesses go almost back to zero for the rotation. This will become clear in the future, but for now, my approach to model the supports is going to be by adding a new node and adding springs to that new node. Now, I am very well aware of the shortcomings of adding a new node. If I add a new node to my model, then I'm adding 6 degrees of freedom, which means I'm adding potentially up to 6 new equations to solve. But that's a risk I'm going to take because I want to give one unified way of defining supports, which is basically to define a spring support and play with the spring stiffness, going all the way up to a high value if it's fixed or to a low value if it's free. So this is my approach onto modeling the supports. We continue with this. So since I ask the user to give me those things, it means that I should tell them exactly what it is, right? Okay, so the user is now going to give me those values. It means I need to store them. So in the properties here, I'm going to store those values. So it will have an ID. It will have the spring stiffness in X. the sprint stiffness in Y. U stands for displacement, and R stands for rotation. And now I'm going to store them during the constructor. So here, let's store them. Object.id equals id, object.kux equals kux, and so on. You know the drill. Fantastic. So I think I have defined all the things inside the support. So this should end the constructor of the support. Also, the support should tell us more about itself. Now here in the properties, I am going to also have me two properties that should be private, but I will just keep it public for now. I want to say here, k u rigid, and I will give this a huge value, like 10 to the power 15. And ku free, this is the spring constant when I want to simulate rigid, which is a very high stiffness. And ku free, which I will give this to be the value, a very small stiffness value. This means that my results might be a little bit erroneous. I would have like a 0.0001 error in those, but it will be negligible, and I will show you this during the later stages of these videos. Here I'm going to say kr rigid, and this is 1e15 once again, and kr free, which is going to be 0.001, or in other words, 1e negative 4, if you want to write it in the scientific notation. The e here is not the exponential. The e here stands for 10 times 10 power something. Now I want him to tell me something about himself, so I will say function toString for object. Now in the toString, I want him to give me a code. So similarly to robot, I want him to give me a code like f for free and x for not free. So how do I do that? Well, I'm gonna fprintf first, and I'm going to ask him to tell me support number and give me the index of the support, or the ID, which means here I need to call the object.id. I'm not giving a new line here because I'm going to add the code of it. So as a matter of fact, I can start opening the bracket here for the code, and now I need the code for this thing. So how do I do that? Let's see. So if object.kux is equal to, and here I can use the equality sign because this is something I will do by hand. There won't be numerical errors. If this kux equals object.ku free, I think it's called. Yeah, ku free. Then I'm going to add to my sentence free. Otherwise, I will add to my sentence fprintf x, meaning not free. And I will end the if statement here. I don't think I need those brackets. This is like one of the relics of using C#. So I think they should do the trick. I think I messed up my, is it written like this? Yeah, kux is written like this. Okay, fine. Now I'll have to rinse and repeat, so I'll have to copy and paste. I never like copy pasting, but this is one of the exceptions where I can do it, because I could like punch in a method for this. Is it really worth it to punch a method? No, it's just two sentences. You see, one of the basic principles when you program is if you see yourself copy-pasting a lot of code, this is signs that you need to change and you need to add a method or a function that encapsulates this repetitive code. I don't like really copy-pasting code. It is what it is. In the end here, I'm going to fprintf and close the bracket. Because I opened the bracket, I'm adding those sentences, I opened it. Now I'm going to close it, hit the enter key, and that's that. So this is how I am going to report the support. Okay, so I think we have done programming the STRSupport. It's time to try it out. Now there is a lot more to be done here. The STRSupport must be connected to the controller, who should be able to know exactly how many STRSupports he has and add STRSupports and be able to report the STRSupports. That's something we have done yet. We have not done yet. I will do this later. Okay, so let's try this out. Support 1. Let's define us a pin support. So I'm going to call the constructor STRSupport, and it needs the ID. Let's give it a -1 for now. For the name, I'm going to call it pinned. For the KUX, now a pin stops movement in every direction except the rotation. So I'm going to give it a stiffness. And this is basically the rigid stiffness I defined before. And I'm going to give it a free stiffness for all the other directions. A very small stiffness. Okay, now I'm going to ask the support 1 to report itself. So let's see what will happen. Let's run. Okay, it seems it's running, and we do have a support. Okay, this is the reporting system. Let me show you. If you put here a tick mark and run, let me close this now. We are standing here. I think I will not let him render anytime. We're standing here. He's trying to define a support. So if you step in, it will go to the definition of the support, taking my values, which he will assign. That's good. Then, when he goes to report itself, it will go here basically. And it's going to report itself. So it's going to first of all give the object name, which is pinned in a sentence. So if I step in, you can see it wrote the first part of the sentence. Then it another step in, continues writing the index, the ID I mean. Then it starts the if statements, checking. It's not free, so it tells you an X. Not free, so X. Not free, so X. And then free for the rotation. Okay, I think we're doing good. Then it closes and pushes the enter key. Yeah, I think that's perfect. That's exactly how it's supposed to be. So yeah, for now, that's everything I wanted to talk about today. We still have to take the support, let the controller deal with it, and also let the str node have the ability to have a support, because an str node can have a support. It doesn't do a support, it has a support, and because the verb here is has, it will become a property. But that's something for next time. And of course, once again, the entire source code is available to media channel members. However, if you're not a channel member, you can easily follow along my video and write the code yourself. There is nothing that I am hiding from you so far, so enjoy. So yeah, that's everything I wanted to talk about today. I hope you enjoyed. And with that being said, I want to give a support-sized shout out to my dear channel members in the contributor level and the helper level whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting and so on, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video. Bye bye.